Hello, in our last two lessons, we have done the equations of a line in 2 dimensions and 3 dimensions. And similar with grade 10, we have done the find the point of intersection of two lines. And we are going to find the point of intersection for the two lines in 3 dimensions. So in 3 dimensions, there are 4 possibilities. In 2 dimensions, we have 3 possibilities. So the 3 possibilities is we have 1 point of intersections, and we have 0. If the two lines parallel, we don't have any point of intersections. And also we may have the line, two lines, they are the same line. So we have infinite point of intersections. So for the what we have done before, we have these 3 cases, okay? 1 point of intersection, this is just a normal case, and if two lines parallel, they will never ever intersect, so there's no point of intersections. And if two lines, same line, it will have infinite. And in 3 dimensions, you are going to have 4 possibilities. So the first one is just a regular one, have only 1 point of intersections. And second one, they are the same line, so you will have infinite point of intersections. And if they are parallel, they will never ever intersect with each other, so 0 point of intersections. And in 3 dimensions, there is another possibility if they are not parallel, but they are in a different plane. So this is in one plane. So if this is in one plane, and we have another one in another plane, that plane is parallel with another one, but it's not in the same plane. So they will never ever intersect with each other, but they are not parallel. The plane parallel, but the lines not parallel. So 0 point of intersection. And also we could draw the 2 planes parallel, but you could have more planes that you have this line, okay, not only one. So if the direction vectors are equivalent, it means they are going to be either parallel or coincident, the same line. If the direction vectors not equal, then they are either skew, not in the same plane, or they have the 1 point of intersection. So now we are going to see how we are able to find the point of intersections for the 2 lines and determine if the following lines intersect. If they do, then find the coordinates of the point of intersection and determine whether they are parallel or distinct or skew. So first thing, this is we call the symmetric equation. So we have the direction for the first one is 2, 1, 3. So D for the first one, the direction vector for the first line is 2, 1, 3. And for the second line is 1, 5, 5. The reason why we want to write these direction vectors out, we want to see if they are parallel. Parallel means they are the numbers x, y, z coordinates will be multiplier of another one. It looks like they are not multiplier of 1, 3 to get 5, 5, so they are not parallel. not parallel, so they are going to be skew or in the same one, in the same plane to get one point of intersection. So this is the equation. We could go review a little bit the equation of lines. This we call the symmetric. So we have equation of lines. We have different format. So vector equation is r equals r0 plus t times direction vector of the line. So r0 is a point on the line, and another one is parametric. Parametric equation, just write the x, y, z component out. So this one is x0. This is we could write d1 is x direction. So x0 plus t d1, then y direction, y0 plus t d2, y direction of the direction vector, and z0 plus t d3. So this is a parametric equation and also the symmetric, the given symmetric equation is solve for the t. So x minus x0 over d1 equals y minus y0 over d2 equals z minus z0 over d3. d1, d2, d3, they are the direction vectors of the line. x0, y0, z0 is a point on the line, okay? So, and it asks you to find the given lines that pass through their point of intersection. So this is just 3 different formats for a line. Now we are going to solve it, and this is the first time we start to solve a point of intersection for the 2 lines in 3 dimensions. And for the symmetric equation, we have 2 of them. We want to write them in the parametric equation form. So we call this is a first line. This is our second line. So x direction. The reason why we want to write this in the parametric equation, because then the corresponding x equals, corresponding y equals, corresponding z equals, we can get rid of the x, y, z from the 2 lines. So that is what we want, to get rid of the x, y, z, okay? So just write x, y, z component out, and because we want to find the point of intersection, it means at the point of intersection, the x, y, z, they are going to be same because it's the same point. So x equals, we write this one equals t, so just times t plus x0. So it will be 2t plus 7 times t, move the negative 2, 1t plus 2 times 3 minus 6, 3t minus 6. That is a parametric equation for the first line, and for the second line we could write it as equals s. So solve for x, move the 1 to other side, then move negative 3 to other side. So 1s plus 3. 5 times s plus 8. Then 5 times s plus 13. So these are our 3 equations for the parametric equation for line 1, line 2. Then we let x equals, we are going to have 2t plus 7 equals s plus 3. And the second one, t plus 2 equals 5s plus 8. And last one, 3t minus 6 equals 5s plus 13. And you will see from these three equations, we have only two variables. So normally, two equations, we only need two variables. Two variables, we only need two equations. We have three. It will happen if we solve for the s and the t and sub into the third one. If the third one, left side, right side, doesn't equal, then it will come out with a zero solution. So they don't have the point of intersection. So two variables but three equations, it will happen that no solutions if the third one doesn't satisfy the solutions from the other two. So now we want to see how. So equation 2, equation 3, you could pick any two of them to solve, and the last two, we find out the number at front of s, they are same. So from elimination method, if we subtract 3 from 2, then we just subtract accordingly. So t minus 3t plus 2 minus negative 6 equals 5s minus 5s is 0, 8 minus 13. Then collect the like terms. T minus 3t is negative 2t. 2 minus negative 6 give us 8. Then we move the 8 to other side. It will give us 8 minus 8, 0 minus negative 13. Then we move the negative 2 to other side in order to solve for the t. So we have the t equals 13 over 2. Then we could pick one of the equation from 2 or 3. So we may pick 2 because 1t at front. So we sub t equals 13 over 2 into equation 2. Then we are going to have 13 plus over 2 plus 2 equals 5s plus 8. We want to solve for the s. We want to move the 8 and the 5 to other side. When we isolate s, we do the backward of BADMAS. So we move the adding subtracting first. Move the plus 8 to other side. Do the opposite operation. So we collect the like terms. Then 13 over 2 plus 2 minus 8 equals 5 times s. Then we move the 5 to other side. Then get your calculator out. You will find out s approximately equals 0.1. So this is s, this is t. Then we want to find out the third one satisfied or not. So we sub x approximately 0.1 is equals, not approximately, sorry. It just equals its exact value. So it equals 1 over 10. You could just use it at 0.1. So sub s equals 0.1, t equals, we could round it to decimal 6.5, and most of the time, if not divisible, I highly encourage you just keep them in the fraction. We want the exact value. So sub s equals 1 over 10, t equals 13 over 2 into equation 1, because we didn't use equation 1 yet. So it should satisfy equation 2 and equation 3 because we solved s and t from these two equations, but we need to make sure the left side of equation 1 to see if it's equals to the right side of equation 1. So this is 2 over 1, then times it, 13 plus 7 is 20. The right side, we double check it. If equal means this is our solutions, and we will have a point of intersection. If not equal, it means we don't have solution from these three equations. Then no solution means no point of intersection. So sub this one to the right side, 1 over 10 plus 3. Obviously, we are going to have 3.1, so left side is not equal to the right side. No solutions. So no s and t value will make these three equations true. Then if we couldn't get st value for these three equations true, it means we don't have xyz. xyz coordinate same from these two lines. So the equation will be, therefore, the two lines are not intersect. And we are going to see if they are parallel or they are skew. So we have known that the D1 is 213 and D2 is 155. They are not. So D1, we are not able to find a number at front times D2. So it means they are not parallel. So D1 is not parallel with D2. So the two lines are skew. So it's just one is here, another one is another direction, but they are not going to intersect. It's in the space on the different plane. This is this plane, this is another plane, and they are parallel. So this is for the first question, to solve for the point of intersections from two lines. And for the two lines, they have x, y, z. And we have two variables, so we just use two equations, solve it, and sub into the third equation to see if the left side equals right side. If they are equal, then we have a point of intersection. We just sub in the t or s back, and we have the x coordinate, y coordinate, z coordinate. We have the point of intersection. Otherwise, if not equal, it means they are not going to have a point of intersection. Okay. And now we are going to see another example. Example 2. So it asks you to determine if the following lines are, intersect or not. If they do, then find the point of intersection and determine whether they are, if they don't intersect, then find out if they are skew or parallel, if no point of intersection. So this is in another form of the equations is called the vector equation instead of the symmetric. And we are going to do the same thing. Step 1, we want to convert them into parametric equation, because once we write it as parametric equation, then we are able to get x equals y equals z equals to get rid of the x, y, z. Then we only have the s and t left. So we just pick two equations, solve s and t, and use the third one to check if they are going to intersect as one point. So this is line 1, this is line 2. So parametric equation is x, y, z equals the component vector first plus first. So 5 plus 1 times s. Second one, 11 plus 5 times s. Third one, 2 minus 2 times s. The second equation, x, y, z equals 1 plus t, negative 9 plus 5t. So it's just second y direction plus y direction, then last one plus last one, 9. T times negative 2 is negative 2t. So we have these three equations. Then we want to find the point of intersection. It means x equals y equals z equals. So 5 plus s equals 1 plus t. 11 plus 5s equals negative 9 plus 5t. And 2 minus 2 times s equals 9 minus 2 times t. So equation 1, 2, 3. And also we could find out d1 is 1, 5, negative 2. d2 equals 1, 5, negative 2. They are equal. So d1 equals d2 all times with an integer or a constant, then it means they are parallel. So it's direction, actually the same direction. So they are parallel, and we want to find out if they have infinite point of intersection or 0. So we want to solve it. And this time we could use a different method. Instead of elimination method, we have one of the variable one at front, so we can isolate it. So this time we use a different method. You could continue use a elimination method. So substitution. Substitution method, then substitution means we isolate one of the variable in one equation. So isolate s in equation 1. Then we have s equals 5, move to other side is negative 5. So we have negative 4 plus t. We call this equation 4. Then we can sub this one into another equation. So this one we call the sub. We substitute twice for substitution method. Sub equation 4 into equation not 1 but another one. So we could sub in equation 2. We have 11 plus 5 times negative 4 plus t equals negative 9 plus 5t. So substitution method means we replace this s with equivalent of s. Then we expand it in order to collect the like terms. So we have 11 minus 20 plus 5t equals -9 plus 5t. So we move the t to other side to collect the like terms, then move the 9 to the left side. So opposite operation will be plus 9 plus 5t. Opposite operation is minus 5t. Then we are going to have 11 plus minus 20 plus 9 give us 0. The right side 5t minus 5t is 0. So it means you have infinite point of intersections for this equation 1 and equation 2. So then we want to check. Okay, so any s and t will satisfy equation 1 and 2. So equation 1 and 2 is kind of you have same line, but we have to check equation 3 to see if s and t satisfy equation 3. So left side, L dot s means left side. So 2 minus 2s right side 9 minus 2t. So if we just give s equals 1, t equals 2, then we sub in because it's any st satisfy this equation. So okay, we give s a t a number, then we sub in this one. Okay, so t equals 1, then s sub in is -4 plus 1 is -3. So as long as st satisfy, as long as s equals -4 plus t, then it will work. So st couldn't be any number as long as s equals -4 plus t. So we just pick a random number, sub in. So 2 minus 2 times -3 give us 8. Then this one, 9 minus 2 times 1 give us 7. So left side is not equal to the right side. It means the equation s equals -4 plus t for any st doesn't work for equation 3. So no solutions again. And this time, because D1, D2 is parallel, so we are going to see the two lines are parallel but not the same, not coincident, and distinct. Distinct means they are the two different lines, okay? Not coincident. So this is a solution for the example 2. Then we are going to continue to find the equations. The point of intersection continue, okay? So this one, so if they exist, find the x, y, z intercepts of the line with x coordinate, y coordinate, and z coordinate. So this one is kind of, we have x, y, z. Then in order to, so this x direction, this one will be a comma 0 0, and y-intercept 0 0 b, and z 0 b 0, and z-intercept will be c. Okay, so to see if they have the x, y, and z intercept. So if we have a line just randomly somewhere, you may not have any of this XYZ intercept. So the next one, so the first one we want to find is question for the x-intercept. We need to find y equals 0, then see if z equals 0 or not. If you have y equals 0 but z is not 0, then you don't have the x-intercept. So we write y equals 0, then 3 minus t equals 0, give us t need to be equal 3. Then we sub t equals 3 into this z equation. So negative 6 plus 2 times 3 give us 0. Then it means we do have 0, 0, xy, yz coordinates 0. Then we just need to find x. So x give us 22 minus 5 times 3. Give us 22 times 15 is 7. So we know that the x-intercept is 7, 0, 0. So it's 7, 0, 0 is the x-intercept. The line does intersect with x-axis. The y-intercept. Y-intercept we need to write x equals 0, and also we need to check z equals 0 or not. So x equals 0, we have 22 minus 5t equals 0. 22 equals 5t, so t equals 22 over 5. Then check. Sub in the z. Negative 6 plus 2 times 22 over 5. We know this is not 0. So it means we are not able to have x and z. X and z both 0 doesn't exist, so no y-intercept. Then we check if we have the z-intercept. For z-intercept, we need to let x equals 0, then check y equals 0 or not. So from here, we know that t equals 22 over 5 will give us x equals 0. Then we check y equals 0 or not. Sub in y equals 3 minus 22 over 5 is not 0, so it means no z-intercept. Okay, so this is how we do it. We only have x-intercept is at 700, so it's not always a line will have x, y, z intercept. So a linear system is said to be consistent if it has at least one solution. And from the above, example 1, example 2, you will see both the linear system, they are not inconsistent. So a system of linear equations may have 0 point of intersections, 1 point of intersections, or infinite point of intersections. Or 0 point of intersections. For 0 point of intersections will be either parallel or skew. So, and because we don't have any examples for consistent, if it's consistent, it just means that you sub into the third equation, it will give you the left side equal right side, and the third equation give you the z coordinates, and you sub in the st, sub in the s, you will find the xy coordinates, then the xyz, you sub either s or t back, you will find the point of intersection from those equations. But only after the third equation, left side, right side equals, then you find the point of intersection. So this is what we have done for today. Find the point of intersection of two lines. So we want to convert the two lines into parametric equation. The reason is we let x equals y equals z equals to get rid of the x, y, z. Then we only have two parameters left. Then three equations, two variables, we only pick two equations to solve and use a third one to check. If the third one, left side equals right side, then we have a point of intersection. And sometimes you have infinite. So once we have the TS solved, we can sub the T back. Then we have the X, Y, Z coordinates. That is our point of intersection. Okay. So that is all for today's lesson. Thanks for watching.